How I got into being interested in making the builds go fast was a moment of personal frustration. I was debugging a problem that only happened in production, and I had to repeatedly push builds to figure out whether or not I'd fixed the crash. And each iteration was taking me 15 to 20 minutes, and the only thing that I was doing in between was saying, hey, by the way, don't optimize this line of assembly, or hey, don't optimize that line of assembly. And I knew that we could have life be so much better. So this is a very famous thing from Randall Munroe, right, like slacking off because your code is compiling. So what if we could avoid needing to have that excuse? So you might ask, why am I frustrated with 15 minutes? And it's because I had personal experience of when I started Honeycomb in 2019. I remember we took drastic action when our build time crept past 15 minutes, and we actually ended up changing CI providers in order to get it back down to 8 minutes. But over the intervening couple of years between 2024 and 2020, we'd had a little bit of regression. And this is what our build time looked like. It was pretty consistently 12 minutes, but every now and then it would take 15 minutes. And sometimes you get an especially fast build at 10 minutes, but nowhere near the 8 minutes that we were getting back in 2020. So when I look at this and I see, why did this happen? The answer is we wrote more code. We're a startup. We write code, we add new features, right? So if I look at the code base size and the number of commits per week, basically you can see the number of commits per week was quadruple what it was back in 2019. And I was actually, just before the talk, seeing whether I could update this. And I cannot get you an update of this in the Honeycomb tool itself. But yes, basically every year, something like a third of our old code base gets obsoleted, and then we add about 50% more code. And that's basically what happens with the shape of our total GitHub repository. By the way, this tool is called Git of Theseus. It's really cool if you ever want to look at the history of how your Git repo has evolved over time. And we thought, when we originally did the exercise of moving to Circle CI in 2020, that we were going to be, having a great time because Circle CI would magically solve all these things for us. And it was great. Don't get me wrong. Circle CI is wonderful because it enables you to do things like, hey, if I have 1,000 different tests and I have 4 different workers, let's assign 250 of them to run on each worker so that they finish all about the same time. And they even do things like, finding the tests that are taking the longest and not assigning them all to the same worker, so you don't have one worker that takes 10 minutes and one worker that takes 3 minutes to complete. But even then, there is still a little bit of a problem. And the problem was sufficiently bad that there is literally a comment right at the top of our Circle CI build file, which says, I'm sorry if you're reading this, here's everything that we've already tried. So that's how much effort we had put into fine-tuning our Circle CI config. So I knew that something had to give and that we had to do things differently. So why is the build so slow? Well, the good news is because we are Honeycomb, everything looks like a nail when you have Honeycomb. So of course we applied Honeycomb to the problem and we distributed trace to our build system. I highly recommend this, by the way. You don't even have to use Honeycomb. You can use Jaeger. You can use anything you like. But for the love of all you care about, trace your builds because the number of trace stands they'll produce is relatively small compared to the amount of developer frustration and the amount of money you spend on your CI provider that you're going to save. So in this case, what this graph is showing us is that there are 134 spans, 12 minutes, and the tests were taking a while, but there was just a lot of time that we were blocking on the output of something else before we were able to proceed with the input to the next step. And those steps were copying around a lot of data. A lot of data. So what can we do to make these things faster? Well, I alluded earlier to adding more parallelism. And yes, that works up to a point, right? I can say instead of splitting these tests 3 ways, maybe I'll split them 4 or 5 ways. But Amdahl's law eventually takes over. For those of you who do not know what Amdahl's law says, it says that the length of time it takes to do anything gets reduced to the total amount of serial work that you have to perform in the process, no matter how much you improve the speed of the parallelizable bits. So the stuff that's boxed in the red, that's the stuff that cannot be parallelized because every single worker has to have a working instantiated database. Every single worker has to have downloaded all of our source code and installed the Go modules. That you cannot just say, I'm just going to parallelize it away. So we knew that we had to shrink the amount of time to do that, and also you can see that the test splitting was not perfect. You had one test worker that was running tests for about half the length of time as the other one. And then the other problem, the kind of more glaring problem that I was alluding to earlier, is that CircleCI's workers are stateless, which means any state you want to get onto them or off of them, you have to copy it. And we know that under the hood, CircleCI is just using Amazon, right? So these are EC2 instances that are running, and they are reading and writing it to and from S3. Ideally with compression, and they do, in fact, as of recently, they've started using Z standard instead of gzip. But still, right, like, you can see, to copy to and fro about 300 megabytes of cache data of, like, your JavaScript yarn dependencies or something, that's 6 seconds, right, to both read and write it, and that adds 12 seconds to your build, unavoidably, no matter how fast your tests run. And it may or may not be faster to just download them from the NPM repo compared to reading it from S3. But the caches were actually not the problem. 300 megabytes is not that bad. That's dependency data we want to keep warm. But I discovered, because we were tracking all of these metrics, because, again, we treat this as trace data, we annotate it richly, we were recording how much data was being read to and written from, read from and written to the workspace cache. So the workspace cache in CircleCI is data that basically makes it look like you're running on a single machine even when you're running across multiple Docker containers. And the way that they do that is that you specify what files you want to have dehydrated and rehydrated between each step, so that it looks like it continuously ran on the same machine, even if those are multiple steps. And what I discovered was that we're writing our complete n-stripped Go binaries and our complete JavaScript build. All that data was being written to the workspace, and then we had one final step at the end that was building the images and shipping them off to run in production. And that added up to over 3 gigabytes encompressed for each job. And if reading or writing 300 megabytes of data takes 6 seconds, you can multiply it out, and you can see that, okay, it might take up to 45 or 60 seconds to read and write that 3 gigabytes of data to and from the workspace. Not ideal. So did we need to copy all of that data? No, hell no. Because everything deploys today in Honeycomb land as containers, even though originally we were shipping data, we were just zipping up the binaries and storing them in S3 and pulling them from S3 on EC2 VMs. Today we just use containers. We don't need all of these immediate artifacts. We could, for instance, strip the binaries before building them into the image, and then just having some separate process to write the archival and stripped binaries. So we could basically avoid passing all this stuff off from step to step to step by just building it all in one place. So this is what Docker Bake does really, really well. So I presume most of the people in this room, just as a level set, we all know what a Docker file is, right? Okay, great. So a Docker file basically is a mechanism for grabbing a base image and then layering in your source code, performing a build, and then saving the results of that build minus the original source code. And CircleCI does have a mechanism of doing builds, and CircleCI does even also have a mechanism of caching steps where the build where the inputs into the build have not changed. The problem is that also uses that same S3, gzip, or Z standard copying mechanism. And if you are copying in a lot of data, or if you're generating a lot of intermediates, congratulations, you have now replaced a bunch of compilation time with a bunch of I/O wait time. So the cool thing about Docker Bake is that it allows you to compose things. It allows you to say, here's a set of Docker files that all inherit common kind of properties. For instance, maybe these are the version numbers that you want to attach to them, or this is the instance type that you want to build them on, or here are some common variables that you want to pass to all of them. And it allows you to chain inputs and outputs together inside of the same build kit worker. So here's an example. We build our front-end code, and our front-end code basically, takes a bunch of JavaScript and runs Webpack on it and produces a minified binary, right? But Honeycomb also has some functionality for rendering. If you paste a Honeycomb query into Slack, we'll show you a preview of what that query is going to look like inside of your browser. And we do that with a real browser. We use a headless Chromium that is running our real JavaScript code. And therefore, we have to pass the results of Webpack into into the preview process. So this is, in the past, we basically had to manually copy that between build steps and pass it via the workspace. But with the help of Docker Bake, we're able to just say, take the output from the target Poodle.js and to feed it in as one of the inputs to the doodle process. And that enables us to basically allow all these things to happen in parallel. The JavaScript build, the previewer build, the Go binary builds, right? Like we can run all of those things in parallel, and anything that is waiting on an input will just sit there until the output is available. And then it will be able to proceed using the full bandwidth of the machine without having to copy data between different machines. And also, I'm running a little short on time, so I'll just gloss over this. Your security team will love you because this is also, it's included for free that you get SBOMs. Okay. So the other cool thing is I talked about tracing earlier. So we wound up doing a bunch of custom work to add tracing to our CircleCI configs by actually wrapping every command execution inside of CircleCI with a call to our internal Honeycomb tooling. But what if you didn't have to do that? And the answer is the buildkit daemon in Docker and the docker buildx command natively support emitting OpenTelemetry data, which means that you can just, if you have any tracing tool, you can just get the data straight out of the Docker command, and it will show you where are you actually spending your time. Which individual dependencies did you run? And also for each thing that ran, where did it actually, right, like how long did each individual step take? Again, I didn't have to add any wrappers, I didn't have to add any custom instrumentation. It just shows me it was waiting that long for the dependencies, and then it finally started running, and then, you know, it took like 5 or 10 seconds to run, which is pretty cool. Okay, so how did that work out for us? Well, we basically slashed the amount of data that we were transferring to and fro on CircleCI by a factor of 90%. And that made everything go faster. And as a result, we were able to get to having something like a 7-minute build down from 12 to 14 minutes. That was awesome, yay, right? But I have to confess the honeymoon did not last, because we being developers, we added more tests, and we did not change the number of build workers corresponding to the number of tests that we had added. And while the amount of time, so the green rectangle, while the amount of time that we were spending in Docker stayed about the same, the total amount of time it took to run the entire CI pipeline started creeping up again to 7, 8, 9, 10 minutes even. So what if we could use faster build workers? What if we could benefit from actually being able to cache things instead of having to rebuild them from scratch because it's faster than pulling them to and from S3? So, of course, you know, yes, we adjusted the builds and we said, okay, like, you know, we're going to optimize the amount of time it takes to spin up a database, and we're going to fix all of the number of parallel workers on Go tests. But what if we could, instead of, I have to admit, I really do love Graviton 2 and Graviton 3 and Graviton 4 instances, but the hardware running in this MacBook, right, like the M4 chip, it's amazing. Wouldn't it be great if we could do all of our builds on M4? So enter Namespace Labs. So Namespace Labs are basically a bespoke cloud provider, mini cloud provider, that provide ephemeral VMs, which means that you can store on local SSD all of those caches that you previously thought were too uneconomical because they were too bulky in number of bytes to ship to and fro. So we could cache our Webpack cache, we could cache our node modules, we could cache the Go build intermediates, and also when we were actually running those builds, it would go really, really, really fast because the M4's single core performance is just that good. Now, there are trade-offs. I'm going to confess there are trade-offs. So you can see the very variable tail latency, I will say. So we went from having, you know, very rock-solid, predictable, every Amazon instance is the same, and we get a brand new one every single time, and we have to instantiate it from scratch. We went from that to some of the builds going really fast, like 3 minutes instead of 5 minutes, right? Literally 40% faster, to sometimes a build might take the same amount of time and kind of be flat because it was instantiating everything from scratch. And sometimes we would actually overload on the same machine because Namespace Labs is not necessarily giving us a brand new machine each time, because the whole point is that you're getting to reuse machines. What if you reuse the same machine a little bit too much and you're feeding 3 builds to that same machine at the same time? So we also get, so we don't get the OTel output for now coming out of the Docker build daemon anymore, but Namespace Labs gives us a very similar view that shows us, how long we're each step running for, and what's blocking and what's slow. And we also get very nice previews of the software bill of materials. And this is an example of a machine that's actually gotten reused, right? So you can see that one build ran, and then about an hour later, another build ran on it. So each time the CPU spikes, and then it goes back down. But the cool thing is, right, the hard disk sticks around, right? The NVMe SSD with all of those build artifacts sticks around. So the next build is going to be faster than the first build that was run on that machine. And they handle the provisioning and elasticity, so we don't have to worry about it. We only get billed for the number of minutes that we're actively using the machine. But again, that can mean that sometimes things get a little bit backed up on the same machine, which explains this trimodal behavior, right? So cold cache, about 5-minute build time. Warm cache, 3-minute build time. And overloaded machine, well, that might take 10 minutes. So, that's kind of the honest set of trade-offs that we had, but we've decided that for us, it's worth it, right? So you can actually see there, that's the kind of 3 peaks, right? Like the 2 big peaks and then that very long tail in case things take a while. So we found basically that when you make the common case fast, it's okay for it to occasionally be a little bit slower. And even in the worst case scenario of it taking 12 minutes, that is still no worse than our situation in 2024. And our developers have noticed, and they've changed their patterns, right? So for instance, a lot of us have gotten lazy about running make test locally. We just, run the tests for the 1 or 2 things that we changed, and then we just push the branch and see what happens, because no harm, no foul, and it will take less time to run in CI than it would on your local laptop. And we're still pushing things constantly, right? Like every time we see that build creep past, 8 or 9 minutes, we try to get it back down to 5 minutes. And by the way, because I have to work AI into every talk now, this is the year 2025, here's the interesting thing. If we had not optimized our build speed, we would be in a lot of trouble right now. So our number of builds per week has doubled, and that's partially yes. We did hire more developers, so we've added about 50% more developers. We used to have 40 developers committing to production every week. Now we have 60 developers who are committing to production every week, but that does not explain the number of builds doubling, right? So we think AI has something to do with this, that the use of AI has made each developer about 30% more productive. And also, the faster build times might have themselves caused the devs to become more productive. We cannot say this is 100% the impact of AI. But regardless of how you want to attribute it, we went from 80 merges per week to 160 merges per week. And we've gone from 500 builds per week to 1,000 builds per week on branches. So if you think about it, that's about a 5 or 6 to 1 ratio. So that means that in order, whether it's AI or a human writing the PR, it typically takes someone 5 or 6 pull requests to get it right and to pass all of their reviewers' comments, right? 5 or 6 turns before you actually are able to merge it into production. So if your build takes 5 minutes, that's 30 total minutes of build time. If your build takes half an hour, that means suddenly that you're waiting 3 hours at some point in your review process and in your feedback loop before you're actually able to learn to land code. And that is a very, very, very significant cost in terms of developer attention and salaries. So fast builds are not a luxury. They're infrastructure that enables other force multipliers like AI to give you the full impact that you want. So at the end of the day, we doubled our number of builds per week. We cut the amount of time that each build takes by 50%. And we also had our CI bill stay about flat, which is pretty cool, despite the number of builds doubling. So what should you take away? Number 1, data transfer between jobs is something that you should pay attention to. It's not just CPU time. Docker Bake and buildkit can really, really help you with accelerating your builds and getting visibility. Cache locality can matter more than being able to get any number of machines generic off the shelf if having a pre-spun up machine can really make your build faster. And actually work based off of the data and design your system to match what your real world constraints are. Because your architecture should really match your deployment model rather than being an afterthought as far as your CI system. So should you do this at home? Consider doing it if you have multiple related containers or you're building multiple things out of a single monorepo. You're seeing gigabytes of data transferred per CI job, and if you are exclusively deploying to containers. Don't worry about doing this at all. Consider this a cool talk that you went to SREcon and you're going to put on the do later or never pile. If you really are just building one container or you're using many scattered micro repos instead of one mono repo, or if your builds are already blazing fast. And regardless, you should be instrumenting your builds, finding your bottlenecks, because that's money that you're leaving on the table and developer time you're leaving on the table if not. So that's what I have for you. I'm Liz, I'm the field CTO at Honeycomb. I've got some resources for you, I'll publish the slides later. So in case I went through anything too fast, you can go and look at the slides. And yeah, also this talk was composed with the help of AI, but it is not AI slop. I composed the vast majority of it myself. Thank you.